Welcome everyone to Build Your Own Deep Research. I'm Sarah Chieng from Cerebras, and I'm here today with Will Bryk, CEO of Exa. We're super excited to have you all here.
Thanks, Sarah. Today we're going to build something pretty cool, a deep research style assistant that can automatically search the web, analyze multiple sources, and provide structured insights in under 30 seconds. We'll code it up with you.
That's right, Will. By the end of today, we'll learn how modern AI-powered deep research systems work under the hood. So before we get started, let's do a quick overview of what we're walking away with today. First, free API credits for both Cerebras and Exa so you can continue developing after this workshop ends. Second, a complete quick start guide to build apps with both APIs so you can jumpstart your future projects. And third, your very own functional research agent that goes way beyond basic search.
Now let's see what we're building. This is Cerebras' deep research interface. It looks clean and simple, but there's some serious intelligence under the hood. Our coding today will build the functionality behind this. If you notice, it's not just returning search results. It's actually doing real research, searching multiple sources, analyzing the content, identifying knowledge gaps, and then doing follow-up searches to fill those gaps. You might take an hour to do all this work, but this app does it in less than a minute. Your deep research will be 10x faster than ChatGPT's deep research.
Before we dive into AI-powered research, let's talk about how research was traditionally done. In the old days before 2025, researchers somehow used to write their own research papers and reports. Let me walk you through each step as we build this diagram together. So first, it all starts with a research question. Once you have your question, you need to figure out where to look for answers. So you'd branch out in multiple directions, you'd go to the library to search through physical books and journals, you'd do Google searches, and if you were lucky, you'd interview experts in the field. After gathering all these sources from libraries, search engines, and expert interviews, what's the next step? You'd sit down and take notes.
Right. That means reading through literally everything you can, highlighting key passages, writing summaries, and keeping track of where each piece of information came from. You can imagine doing this with hundreds of sources.
And this is where human limitations really showed up. You could only read so much, process so much, and remember so much. Important connections between sources might be missed completely because of information overload. Finally, you take all these notes and compile them into an answer. This is where the real intellectual work happened, synthesizing information from multiple sources into coherent insights.
In reality, research is a recursive process. You never actually know if you found all the relevant information in the first pass, so you have to go back and do it again with your new knowledge. Each loop through this process could take hours or days, and there's always this nagging feeling that you might have missed something important. Luckily, AI can do days of research in 30 seconds.
Now, what do we mean when we talk about deep research powered by AI? AI-powered deep research incorporates all those research steps like gathering sources and analyzing notes, but uses LLMs to dramatically accelerate each step.
For starters, instead of going to the library or searching on Google, we use tool calling with a web search API. In this case, Exa. Our AI system can autonomously break down the initial research question into the web search API calls that would answer the question.
Next, instead of the take note step from traditional research, we have retrieval augmented generation, or RAG. RAG just means that the LLMs get to retrieve from the web before generating, because they don't have the whole web memorized and often make stuff up. With RAG, our web search API gives the LLM fully informed context, so it's super accurate.
Finally, instead of us manually reading and analyzing all of these notes, we let the large language model do it for us. And like traditional research, there's a feedback loop. Our AI system identifies gaps in its RAG output and triggers any new searches if necessary. This loop repeats multiple times until the LLM decides that the answer has been reached.
And because we're doing so many LLM calls, speed becomes absolutely critical. This is why we need Cerebras. When you're chaining together 10 or 15 LLM calls to complete a research task, even small delays can add up really quickly.
So now that we understand what AI-powered deep research is, when should you actually use it? Deep research takes a lot longer than a typical search, but it's perfect for things like answering really hard questions like what project to work on or what's the meaning of life, or keeping up with fast-moving fields like AI or biotech.
Now, let's get everyone set up to build our own deep research systems. You can access the starter code here. This will take you directly to our Google Colab notebook, where you can see the starter code for today. The notebook contains all the code we'll be working with, plus some additional examples and extensions you can explore after the workshop.
First, we need to install our dependencies and set up the environment. In your Colab notebook, you'll see we're installing ExaPy and Cerebras Cloud SDK. Run that first cell to get everything installed.
While that's running, let's go ahead and grab our API keys. You'll need a Cerebras API key, and you can get started for free at cloud.cerebras.ai, and an Exa API key, which you can also get for free at exa.ai. While you're installing these packages and getting your API keys, let me explain a bit more about Cerebras and Exa. First, let's talk about the brain of our operation, the LLM. For today's workshop, we're using Llama 4 17p Scout, which is from Meta's latest family of open source AI models running on Cerebras hardware.
Cerebras' speed is a huge unlock here. The faster the language model can run inference, the less time our users have to spend waiting for the research report to come back. Especially with deep research where we're chaining together multiple LLM calls, speed is super important.
It's a great example of something you can only build with fast inference. Today, most deep research products take multiple minutes to return a report. Cerebras unlocks a completely different experience. We serve the top open source models in the industry with 50 times faster inference than traditional GPUs. This is the actual hardware making it all possible, the Cerebras wafer scale engine, WSE3. It's a massive AI chip that delivers the fastest inference in the world. As you can see in the benchmark, we're delivering 2,800 tokens per second with Llama 4 Scout, 5 times faster than the next best provider.
Now that we've covered how Cerebras will run our language model, the second component is to give our LLM search over the web. That's where Exa comes in. We built our search engine from scratch to connect LLMs to the web. Exa is actually built specifically for AIs, and we've built all the features to make it super simple. For example, we don't just return search results, we return the full content of each result page so that your LLM has full context. In fact, we're actually also the fastest search API in the world.
Now that our API keys are set up, step 2 is all about building our core search function using Exa. Looking at our research flow diagram here, this is the first red box where we take a question and find relevant sources on the web. So let's build this search function and see how it works. In your notebook, you'll see step 2 where we define our search function. Here's what the function looks like in practice. On the left, we're creating a function called search web. Let me walk you through the actual code. Notice in our search web function, we're using the search and contents endpoint. This means that not only are we doing a web search, but for each URL returned, we're also getting the crawled content from that page. We also specify type auto. This is really powerful. It automatically chooses between keyword and neural search based on your query. You don't have to decide which approach to use. Think of it this way. If you search for something like Python programming tutorials, that's clearly a keyword search. But if you search for companies that are disrupting traditional banking, that's more conceptual and benefits from neural search. Exa figures this out automatically. The text parameter controls how much content we get from each source. For deep research, we want substantial content, not just snippets. This gives our LLM rich content to work with instead of trying to piece together tiny fragments. Go ahead and run this function now. Try searching for something like space companies in America and see what you get back. You should see both the search results and the full content from each page rendered as clean markdown.
On the right side of the screen, you can see the kind of results we get back. Notice we're not just getting titles and snippets, we're getting the full content of relevant pages. This is crucial for the LLM to do deep analysis rather than surface level summarization.
Now let's move to the next step in our flow, taking all those relevant sources we found and feeding them to our LLM for analysis. This is the next step in our diagram powered by Cerebras.
This is where the magic of RAG really happens. We're passing the LLM fresh, relevant information from the Exa API web search to work with. And this is where Cerebras' speed becomes critical. We're about to start chaining multiple LLM calls together, so each individual call needs to be fast. A few seconds here and there quickly adds up to minutes of waiting.
Now let's look at the actual implementation. Here's what's happening under the hood. We're taking all that rich web content from Exa and feed it directly to the Cerebras LLM along with our original question. In our Ask AI function, we're using a low temperature of 0.2. Think of temperature like a creativity dial. Lower numbers give you more focused, deterministic responses. Since we want factual analysis, not creative writing, we keep it low. The model we're using, Llama 4 Scout, is specifically optimized for reasoning and analysis tasks like this, and because it's running on Cerebras' WSE3 chip, you'll see responses in seconds, not minutes.
Look at how we structure the prompt. We're not just asking, what do you think? We're giving the LLM specific instructions. Analyze these sources, answer this question, and format your response clearly. The LLM reads through all the sources simultaneously, something that would take a human hours, and synthesizes insights in just seconds. This is the power of combining fast inference with comprehensive source material. You can now go ahead and run the Ask AI function with some sample content. You'll see how quickly it processes even large amounts of text and returns structured insights.
Now let's put it all together into a function called research topic. This is our basic research function that follows a classic flow. Ask a question, do an Exa web search, pass the relevant sources to the LLM, then return a response. If you walk through the research topic function in your notebook, you'll see it searches for sources using our Exa function, filters for substantial content, over 200 characters, creates context for the LLM, then asks the LLM to analyze and synthesize an answer.
The key is in the prompt structure. We're asking for both a summary and specific insights in a structured format. This makes the output much more useful than just a wall of text. Try running this on a topic you're curious about, something like climate change solutions 2025 or quantum computing advances. You should see it finds multiple sources and gives you a real analysis.
In the next and final step, we're going to expand on our basic research model. This mirrors how human experts actually research. Instead of just doing one round of web search and LLM synthesis, after the first web search, the LLM identifies the most important gaps in understanding and does a targeted second web search before producing an answer. Let's take a look at step 5, where we implement a basic recursive version of our deep research. If you look at the deeper research topic function, it does everything the basic version does, but then adds this intelligent follow-up layer. The implementation has 2 key steps. After the first analysis, we ask the LLM, based on these sources, what is the most important follow-up question that would deepen our understanding of our query? 2, we then search for that specific missing topic and combine both layers for our final analysis.
Again, look at the prompt engineering. We're not just asking for more information, we're specifically asking the LLM to identify gaps and formulate targeted search queries. This is much more sophisticated than just doing random additional searches. You can go ahead and run the enhanced version on the same topic you tried before. You should see much richer, comprehensive results.
Now that you have the core system working, let's talk about where you can take this next. The beauty of what we've built is that it's modular. You can enhance any piece independently. Some ideas for expansion include adding more search layers, integrating with specialized databases of academic papers, patents, etc., or adding different types of analysis and sentiment, trend detection, or competitive intelligence.
You could also experiment with different LLM models, add memory between searches, or even build domain-specific research agents for things like market research, academic research, or technical due diligence.
We could stop here, but for those who want to go deeper, we're going to look at the approach Anthropic uses for their deep research agent. This is completely optional, but it will give you an idea of what production systems look like. In the Anthropic approach, a lead agent breaks down complex queries into specialized subtasks, multiple sub-agents working simultaneously. Then the lead agent synthesizes everything together and decides whether to kick off more sub-agents or generate the final report. By splitting the task across agents, you keep the context manageable for each individual agent. Think of it like a research team where everyone has their own specialty.
This is huge for reliability. It makes sense, right? Humans also function better when they're given a well-scoped task versus trying to manage 10 things at once. Also, by running sub-agents in parallel, you can run dozens of searches while keeping the response time manageable. Instead of doing searches sequentially, you're doing them simultaneously. The Anthropic multi-agent research function in your notebook shows a simplified version of this approach. It's more complex, but it is better at handling difficult topics that require stringing together multiple sources.
And that's a wrap. You've just built a sophisticated research system that combines the best of web search and AI analysis. You now understand how modern AI-powered research works under the hood.
Remember, you have free API credits for both Cerebras and Exa, plus the complete code guide to keep experimenting. You should build something cool. The techniques you learned today, RAG, multi-layer search, intelligent follow-up, these are the same patterns used by production research systems that we use at places like Exa.
And us at Cerebras. Now, go build some amazing research agents.